Oh, hi everyone. Good morning, good afternoon, or good evening. Thank you for joining these sections. So today we will have Ziyang here to show you how to get started with AWS Lambda. So the cloud platform we use will be AWS. You don't have to follow along in these sessions, but if you're interested to follow along, you do need to have an AWS account. If your account is already expired for the free tiers, uh, you can use your email to create a new account. And for the more details, you can just go to AWS website to set up your account. And if you are here, and you can start whenever you're ready. Yeah.
Hello guys, uh, I'm Zia. You can call me David. Welcome to today's workshop. So today I will be talking about the AWS Lambda. So first, I'll introduce what is the AWS Lambda function, and then I will demo some hands-on labs and show you how to play with the Lambda function. Okay. All right, so let's get started. So before we introduce the Lambda function, let me quickly go through the idea of the serverless, since Lambda is a serverless architecture. Okay, so let me share my screen. Yeah, can you guys see my screen?
Yes, we can.
Okay, cool. So talking about the serverless. Okay, so let's start by comparing the traditional server-based architecture with the serverless architecture. So the two, I think the representative service here in AWS are the EC2, which is the server-based architecture, and the Lambda, which is the serverless. So let's say we want to host our code somewhere. And if we choose EC2, the server-based way, then we have to provision and manage a server, uh, the EC2 instance, which is kind of the virtual machine. And EC2 have the fixed resources, which means that before you deploy your code, you need to think about how much CPU you need to use, how much memory you need to use. Like you need to plan everything, since it's not that easy to scale up or down. Also, like you need to pay for the instance as long as it's up, like including the idle time, which is not that cost efficient. And plus you need to ensure the availability and the fault tolerance. For example, like imagine you are running a online store, like during the peak hours, like Black Friday, you might need to more resource to handle all the traffics. But during the off-peak hours, you still need to pay for those resources, even they are not being used. So this is the traditional server-based architecture. It's a little bit hassle, but if you go the serverless way, like the Lambda function, things can become much more easy. Serverless doesn't mean that there is no machine to host your code. Your code still running on a machine. However, the AWS host and manage the server for you. So you don't need to provision or manage servers by yourself. And it scales automatically based on the usage. And the availability and the fault tolerance are built in, which means less overhead and maintenance for you. Besides, you only pay for your usage. So no idle time cost. For example, if your online store uses Lambda, during the peak hours, the AWS will automatically scales up the resource to handle the traffic. When the traffic drops, the AWS scales down the resource and you only pay for what you use. So this flexibility can save a lot of cost and reduce the management overhead. Okay, so why we go serverless? Or let's say, what's the benefits do we get as a developer if we choose the serverless way? No server to manage or provision, and the built-in fault tolerance means that you don't need to worry about the setting up or maintaining a server. So AWS will ensure that your code runs reliably and is available when needed. AWS take care of the infrastructure for you. So this means that you can focus more on developing your applications and your codes. So this gives you greater agility and speeds up your application to the market. And it scales automatically with usage. So you don't need to think about what happens if your application suddenly got a lot of traffic. So AWS will handle it for you. Also, you pay for the actual usage, no idle time, and it saves a lot of cost. So imagine that you have small piece of code that needs to run whenever someone uploads a file to your website. With serverless architecture like Lambda, you don't need to keep a server running all the time just for that. Instead, Lambda will automatically run your code when the file is uploaded and then shut down. Okay. Now now we know the idea and the benefits of the serverless computing. So let's back to our topic, AWS Lambda. So what is Lambda? So here is the intro from the AWS. So AWS Lambda is a serverless event-driven compute service that lets you run code for virtually any time of application or backend service without provisioning or managing servers. You can trigger Lambda from over 200 AWS services and software as service application, and only pay for what you use. So Lambda is a serverless architecture, and it's released in 2015. And it's what we call the function as the service. So you write your code, set up trigger, and then AWS can handle the rest. And the great thing about Lambda is that so AWS offer free tier with 1 million requests per month for free. So that's actually a very high volume. Like I used to build internal app to manage all the events. And I checked the bill, like every month, the cost for Lambda function is almost zero. So the free tier is really high and it's event driven. So we will talk more about this later. And let's dive into the core components of Lambda. So Lambda have two main components. First, event source. This could be an AWS service or the customer application that publish events. For example, the event source could be a file upload to S3 bucket or a new message in SQS queue. Like when these events occur, they trigger the Lambda function to execute. And The second component is, of course, the Lambda function itself. So this is your code that process all these events. You can write this in Python, Node.js, Java, and more, like different programming languages. So you can just think of Lambda function as a small focused piece of code that does one job, like resizing an image or process a piece of data. So when events occurs, like the AWS Lambda automatically runs your function and you only pay for the compute time you use. Okay. And there are different ways to invoke the Lambda function. Okay. So synchronized way or the push. So it's directly trigger the function. For example, you can call a Lambda function directly from your application to perform a task and wait for it to complete. Imagine you have a web application where user clicks a button and then this action triggers a Lambda function to process some data and then return the result. Another way is the asynchronous. So it is triggering the function based on the certain event, like data changes or the file uploads. So for example, a Lambda function can process the files upload to S3. So whenever there is a new file uploaded, the S3 triggers the Lambda function to process that file. And it also can be triggered or that in the string-based way. So you can use the Lambda to process the streaming data. This could be used to process the real-time data streams from the servers like AWS classes. For example, you might have stream data coming from IoT devices, and Lambda function can process this data in a real time. So in general, there are two different event models for invoking the Lambda function. One is the push model, like where an event source directly triggers the Lambda function. And another is a pull model, where Lambda pulls an event source, like stream data, and process the event when they arrive. So understanding these models can help you to design your Lambda function for different use cases. And sorry. So let's break down the structure of the Lambda function. So first, of course, the function itself. So this is the handler function. So this is the entry point of your Lambda function, just like the main function in Python or in Java. And the handler functions has two key elements or two parameters. The event object and the context object. The event object contains the information about the triggering the event. So this is actually the key object that you need to play with when using the Lambda function. And the context object provides the methods and properties, the information about the invocations, functions, and execution environment. So this is more like the metadata. Okay. And we will like check what this two things looks like in the later demo. And let's give some use cases about the Lambda function. So for example, file processing. So we can use the AWS S3 to trigger the Lambda for real-time data processing after an upload. So imagine that you have a website where user can upload photos, and Lambda can automatically resize and optimize these photos as soon as they are uploaded. For example, when user uploads a high resolution image to your website, S3 even triggers a Lambda function to create multiple resized version of the image for different display purpose. And you only need to pay when the function is triggered. I think this is like I use many online service like convert PDF to something to doc file or something. I think these things all use the Lambda, or most of them use the Lambda. And another use case is that it can handle the stream data from the service like Amazon Kinesis. For example, you can process and analyze the social media data facing the real time to gather some insights. Imagine you have a stream of tweets coming from Twitter. A Kinesis stream collects these tweets, and a Lambda function processes them in real time, analyzing the hashtags or the sentiment to identify the trending topics, and then store in a DynamoDB. So this is where user can query this data. And also the web application, like it's kind of combining the Lambda with other service like DynamoDB and S3 to build dynamic web or mobile applications. Like you can build a serverless web application where Lambda handle the backend logic, and DynamoDB stores data, and S3 serves the static contents. For example, you might build a simple web application about weather. So users interact with front-end host on the S3, submitting request by clicking a button, and clicking a button will send the request to API gateway, and the API gateway triggers the Lambda function that loads the weather data from the DynamoDB. So this kind of setup is scalable and cost efficient, and is very easy to maintain. So these are the use cases of the Lambda function. Okay. All right. So now we briefly walk through or introduce the Lambda. So let's come to some demo. Let me open my AWS console. Okay, so when we log into the AWS console, we can search Lambda. Go there and create a Lambda function is very easy. Like you can just go the functions and create function. Here we can just create from the scratch. Let's say we make David demo. And you can choose your runtime. Here I'm gonna use Python, but actually you can see the Lambda support a lot of different languages. Okay, and then we can just create a function. Right. So the function has been created. So this is the basic structure of the Lambda. So it has a handler, which is the entry point, and then the code, your Python code here. We can take a look at what the event and the context looks like. Okay, let me make my UI. Yeah, I think this is easier for you to. Okay, void, test it. So we can use a test hello world event with this is the event JSON. Okay, and let's see work. So we can see there are some prints. So this is the event we get from the Lambda, and this is include the JSON we just sent. Okay, and this is the context, including the kind of the metadata here. Okay. Okay, so let me, for example, let me create, if we want Lambda to, let's play with the event. 1 second. Oops. Sorry, I clicked the wrong button. 1 second. Share. It's still not sharing. Okay. Let's see. Like we can play with events like just like, since this is the JSON format, so we can just print the, print the value. Let's see, value 1 equal to equal P1. Okay. Return equal to P1. Okay. But let's test with the test event. So it just return the value. So you can always interact with the event just like how you interact with the JSON structured data. Okay, and you can do some, you can extract the value from the JSON. Let's say you can do some math things, you can process it, or something. You can just define your code here. Okay, so this is one way to build the Lambda function. And But in real life, like sometimes we need to uh, use some packages, right? So we can also like deploy, or we can also develop our code on local and then upload a zip file with all the dependencies. Uh, Let me go to my VS Code. Let me create a new file called Lambda function. Okay. And let's say here I want to use the um here I want to use the bottle 3. Okay. So import for bottle 3, and I need to have a Lambda handler. So Lambda handler with event and context. And so I want to use, for example, bottle 3 to access or to list all the files in my S3 bucket. So I can say bottle 3 dot find 3. And I can define a bucket name. Oh, let me find the bucket. For example, this test bucket. And I want a response 3. Okay. So this is the piece of code that's used to list all the files in a S3 bucket. And here we use the bottle 3 package. So bottle 3 is a Python SDK provided by the AWS, which allows you to interact with different AWS services. Okay. And to add this dependencies to your Lambda function, uh, we can put them into a zip file, and here we can make a new directory called package. And we can just pip install. Okay, so in this case, you install the dependencies in this package folder. Okay, and then we can go to the package folder and add everything into a zip file. For example, my lambda.zip. Okay, and then go back to the previous directory and let's zip add this one to the zip as well. Okay, right. So then let's go back to the Lambda function page. So now instead of editing your code here, you can editing the code on your local IDE here, and then add everything to zip file and then upload it from your local. So for example, this one, the one I just created. And here, since we gonna interact with the S3 bucket, so we also need to give the Lambda execution rule the permission to access the S3 bucket. So we can create an inline policy and we S3 list bucket. And you can also like get object. So you need to specify the permission. You need to give the permission to your Lambda function. Okay. Right. So next, say demo baby. Now the Lambda function can load and list the files in the S3 bucket. Okay. And let's test it. Oops. Hold on. Oh yeah, it's list objects. Okay. Go from web file. Oops. This one. This one. Okay. Task timeout. So Lambda also have the default timeout. So the default is 3 seconds, but this maximum, I think, is accept 10 minutes. Okay. Right, let's test again. Okay, so now it can list all the files in my test bucket. Okay, so yeah, so this is how the Lambda interact with the other service. So you can just use the bottle 3 to do that. And don't forget to give Lambda the right permission. And okay, so now we have go through the two methods like to build a Lambda function. One is in this console, another is like you write code in your local IDE and then upload deploy from the zip file, or you can upload your zip file to the S3 and deploy it from there. Okay, and you can also add a trigger to Lambda function. For example, we wanted to you create a function to regularly uh, check your database, right? Or you want it to perform some cron job. So here we can use the event bridge. Okay. So this here use this schedule expression. So this allows you to set up kind of the current job. Okay. And also we can see from the API gateway or from the S3 bucket, like I mentioned, whenever you upload to the S3 bucket, it will trigger the Lambda. Okay. So these are the triggers. All right. So yeah, I think that's pretty much about like how to set up a Lambda function. So I think in today's workshop, we know what is the serverless architecture, and we have the brief idea of the Lambda function, and also we know like how to create a Lambda function and how to develop the codes. So I think that's pretty much for today. I'll handle it back to Adam.
Thank you, Ziyang, and thank you for giving us introduction to the Lambda. I believe it's going to be very useful tools, no matter if you want to become a data engineer or machine learning engineer. And Lambda is one of the very important piece for you to start a data pipeline or machine learning pipelines. We hope you found this section is useful. If you want to learn more about like data engineer, machine learning engineer, or data scientist, and you can go to our website, and I will post it here. So you can go to our website to learn more about the like cloud platform and service you can use. And again, thank you, Zia, and thank you everyone to join. I will stay here for a few more minutes just in case if you have any questions to the Lambdas or any like questions about the career. And yeah, just feel free to ask. I'll post in the chat. And if you no more questions, I wish you have good rest of the day. And we will constantly have these events. And please stay stay in our meetup events and learn more about that. So the recordings will be available on the YouTube. Yes. So the recording it may available, some not. It's based on our YouTube channel management. And but if you miss any part of these sections, I think you still can have access on the YouTube. but we may have to edit it or make some changes, and so it may not available for tomorrow. So if you still need to complete some of these hands-on exercises, I'd recommend you go to the YouTube and look into the recordings, just because it may not available tomorrow. Any other question? So if no more question, again, thank you everyone to join. And if you still have a question, feel free just to stay here and ask me or post in the chat. I will respond to you.